Hello everybody. I was going through one of the last labs in the switch side of CCNA 3 and 4, 641, which is basic inter VLAN routing, which is how you get all of the VLANs that you've created this far using BTP and stuff like that for the replication from the server down to the client. This is how you're able to get them to speak to each other and stuff like that. So like, your end users to your printers and stuff like that. So into your servers and things like that. The thing that at the very bottom of the 641 lab document, she's got or I'm not sure if she did it or if the the book transcribes it for her, but there's an output for the running config that all you have to do is copy and paste in there. That's actually really convenient when it comes to setting it up time because, quite honestly, if just by going into here and I actually wrote down uh, the requirements for the lab. Now this is a brand new router, so it's pretty obvious that there's nothing on here. It is an 1841, and I see it's running 12.4 release, which is actually what you're going to find in the CCIE lab. It's actually what I'm running on all of the routers and all of the other programs that I have, GNS3. But when I was going through, and I will bring this in and over here, as you can see, I'll minimize this. This is the router, and then you have your fast Ethernet .10.20.30 interface. It's a virtual interface. It allows you to scale your network. Now, as you're going through, you're going to see encapsulation.1q10. Well, I've been asked by a friend of mine who does a CCNA class and another elsewhere, not here at Gateway, but he's a friend of mine from Florida. He asked me, what does that mean? Well, basically, encapsulation.1q10, in order for you to be able to route your VLANs, you have to encapsulate this trunk connection between the switch and the router's fast Ethernet interface so that it speaks the same language. You can't have ISL trunking on this interface and .1q up here. It's not going to work. ISL is Cisco proprietary, so you could run ISL between Cisco switches, but nothing else. So if you're running you have a Cisco switch and as your maybe your core switch, your BTP server, your root bridge, and then you have like a bunch of D-Link switches that are dumb, and you just want it to be in charge of everything, or it's a basic managed switch where you can put certain ports and certain VLANs. It gives you some scalability. Well, .1q is the industry standard. It's the IEEE 802.1q trunking method. It's used with spanning tree, which I'm sure if you notice, this is actually 553. If you read the very top, I haven't saved it. I just basically added a router and a server to it, and that's all I do is I'm going through. I keep the topology the same. I just change the configuration around. I just save it. Instead of having to reset everything up, I just reinitialize everything with new config. I copy it over. I do this on a regular basis. So as you can see, I got all the green lights to light up, and all I did was I looked at I did a show interface trunk to see which ports were, which VLANs were going across which ports and stuff like that. Then I did a show spanning tree, and I was able to see which what the root bridge was for different VLANs, and I played with it for about 5 minutes, and then eventually I realized that I had to lower the priority on my VLAN 1 in order for it to get to roll on here, and because switch port 4 was down, it was blocking, so I had to lower the priority on this guy down to 4096 so that it would become the root bridge for VLAN 1, and then all of a sudden it lit it up. Now I have consistent traffic going across all links. So this is what you would do if you wanted to load balance across all of your spanning tree links. You're not gonna run into this very often in the real world. Um, it's a good thing to put on your resume that you know how to load balance using spanning tree and stuff like that. But when I say you're not going to run into this a whole lot, typically it's already been done. I mean, there's unless you have a massive network that you've got hundreds of switches. Now you're not really going to see it too much. And a lot of places nowadays, the 2960s and above, the 3550s and stuff like that, they're going to have gigabit what they call a GBIC. It's a gigabit interface card. It's basically running fiber between the switches, and you're going to see fiber connections going in between. So if you click on it here, I'll highlight this. Down at the very bottom, you'll see. Oh, this one doesn't have it. What about this one? Okay, they don't have it. Maybe it's a 2960. Maybe it's a 2960. 2960 does have it. So you see gigabit Ethernet, 1/1, 1/2. But as I was saying, you have the 2960 has the capability of gigabit, where this one doesn't. That's why I think she has it set up to where you have it. I typically use 2960s if I can, I use a 2960. I'm actually looking at my two 2950s right now, and neither one of them have gigabit slots. But you'll run into some places where they'll have they call it stack-wise, and what it does is looks kind of like an HDMI cable. In length, it's about 10, between 6 and 12 inches long, depending on your span. Usually closer to a foot. And what it does is it clicks in the back of your switch, and it allows you to run what they call a backplane extender. And what that does is it makes two switches look like one. It just combines the interfaces. So it takes two 48 port switches and makes it one big 96 port switch. And so that you eliminate spanning tree completely out of your domain. It's whatever the backplane is capable of handling and stuff like that. So it's and those things are good for, I think, 10 gigabit. So my 3-year-old keeps walking in here bugging me. But anyway, that's basically what you'll see. But anyway, moving forward, I've already got the VLANs configured on here. As you can see, they're already set up, and I've got the interfaces the way that they need to be set. So I am going to take this, and I'm actually going to cover this up real quick, just for a quick second. And as you can see, if you just copy and paste this section right here and copy it in, it'll work in your router right here. But one thing I've noticed, if you're doing it in Packet Tracer, it doesn't work that well. It actually freezes. So if you copy it to a Notepad document first, like I did here, okay. But what I do is what the heck? That's what happens when you get too many programs running on your computer. What I do is when I'm setting up, like this will be my VTP server. I'll set up VTP. I'll create all my VLANs. It'll replicate down to here and to here, and then I will figure out the load balancing accordingly, and then I'll configure my VLANs on here. Well, your VLANs will already get configured here. So the basics point of this is to give you kind of a lowdown as to what you might see. Now this is in Packet Tracer, as you can see. I'm going to quickly configure the router so that I can get it up and running. And I don't really need to see the what it wants you to show when it comes to setting up the routing for VLANs, because it shows you right here, interface fast Ethernet 0/1.1. What I do when I'm setting up VLANs, I always associate the VLAN number with the IP address. So that's basically what I do. I always associate the VLAN number with the subnet, because that's how you keep it straight. If you associate, you go like VLAN 66. .1Q22, and then you put some other crazy number, it won't be consistent, and you'll have a problem troubleshooting it later. You'll be like, well, what was he doing? So that's what I do. But anyway, enough chatter. So I will, as I'm going through, see, I sat for too long. Enable config T, and then I actually, if you type in do show IP interface brief, there's nothing set, so I had to figure out where I need to go. So I've already got, I think I've got, I don't have IP addresses set for this stuff yet. And I don't. So this will actually be a quick config. You're saying quick, you have nothing set up, so it should go pretty slow, right? Well, it depends. I've been dealing with Cisco for over a year now, so I'm actually really fluent in a lot of the commands. So I will do a lot of shortcuts and explain as I'm going. But what you want to do is you want to go interface fast 0/0, and you want to make sure you're getting the right uh, Ethernet FAT 0/0, and so you want to come up here. By default, it's going to show on this one as down as well until this guy gets turned on, because right now, in here it'll show up physically, but nothing going across the wire, no data link, no protocol. So I'm going to type in .1, or actually I should say, and then no shut. How about I could type, no shut. Now what that does is it bring, well, I lied. Did I turn the right interface on? FAS 0/0. I'm in FAS 0/0. That's weird. Anywho, so we're gonna go do show IP interface brief. Up, down. Oh, okay. Well, maybe I called myself a liar. Click in there, enter Cisco, enable class, and then show IP interface brief. And 5 is administratively shut down. Okay, so config T interface fast 0/5, no shut. There, it's up. That's why. It does. Oh, you know what? I remember. I copied and pasted config in, and I turned everything down off. By default, it's down, not administratively down. Down just means that there's no data going across the wire. Eventually, you'll see up on line, right? It'll say status. This right here actually means plugged in, and then if I scroll this over, protocol means it's sending data across the wire from device to device. So now if I do a end and then hit up, now it's up. So there you have it. So now I'm going to minimize the switch, bring the router back over, and I'm going to start blowing through the config real quick. It shouldn't take too long. I'm going to actually exit so you guys can see what I'm doing. So I'm going to go interface fast 0/0 dot, and then the VLAN number .1. Enter. Now it's changed to up. Now I'm going to type in. You're going to go IP. I think I'm going to be able to do it this way. 172.17.1.1. Okay. This is actually what I was hoping for. Configuring IP routing on a LAN subinterface is only allowed if that subinterface is already configured as part of an IEEE 802.10.1Q or ISL VLAN. What that means is you have to tell the router what VLAN it's going to route for. It assumes by default in the configuration, or actually by the iOS, that when you're setting up a subinterface that you're going to be routing VLANs. That is what is defaulted to. That's the iOS saying, hey, I know I'm smarter than you. You're missing something. So what you have to do is you have to type in encapsulation and then a question mark. It only gives me one option for this, but if you were on a real router, it would give you like, I think 4. I don't remember what they are. When I'm done doing this, which should be done in the next couple of minutes, I'll fire up, what is that called? GNS3, and I'll show you how that's a real iOS. .1Q. And then the VLAN number, 1 through 1005. Those are the VLANs you can use. So, which one is this? This will be 1. Question mark. Native. Is this the native VLAN? No, it is not. Native VLAN right now currently is 99. That will also be your management VLAN. If you have a situation come up to where you have, let's say for instance you have a VLAN, native VLAN on this guy is 10, and native VLAN on this guy is 20. And this guy starts sending information over here, this guy's sending information over this way. What will end up happening is you'll have a thing called VLAN leaking, VLAN hopping, which means it doesn't know when to stop it. There's no like dedicated path for the VLANs to cross over with from switch to switch. So what will end up happening is when you're if you have a mismatch, it's not going to be able to stay in the same tunnel, if you will, because what ends up happening is VLAN 10. The best way to describe it, without saying too many times or so, the best way to describe it is each one of these trunks allows you to have a certain amount of VLANs going across it. So, I mean, you can have a lot of VLANs, but the point of the native VLAN is so that everybody is using the same native VLAN. If you have a native VLAN mismatch, then you're going to have the chance for VLAN 10 and VLAN 20 traffic crossing into each other. And then that's how hackers get in. That is how your MAC address table gets flooded. That is how lots of other things can go wrong. So I can't really think off the top of my head of any more that are going to be either going to jump off the top of my head and be like, oh, I've seen that before. But just be aware that if you have a native VLAN mismatch, you will have issues with your trunking, with your encapsulation, with your routing. You'll have packets going missing, you'll have a lot of errors on interfaces, and that's actually how you'll do it. Because actually what I'll do is I'll come back over here and enter. Okay, and then what I'll do is I'll have to, because I do this a lot of times at work, I'll do show interface fast0/0. Okay, what this does right here is it tells you everything you need to know about this guy right here. What it will tell you is it's encapsulated as ARPA right now. ARPA just means it's standard. Queuing strategy is first in, first out, which means the first packet that comes in is the first packet that leaves. Now, if you look right here, what does that mean? 0 input error, 0 CRC, 0 frame, 0 overrun, 0 ignored, 0 abort. When I'm troubleshooting a router, I always check the interface, because it'll tell you what's the bandwidth. Well, the bandwidth right now is 100,000, right? 1,000 kilobits? Yeah, so it's 100,000, that's what, 1 meg? Something like that. The MTU is 1,500 bytes. That's not going to change. Reliability, it's directly connected, so it's going to be 255. But when you have an issue where native VLAN mismatch, you have a lot of duplex mismatch, a speed mismatch, or something else going on, that will show up right here, or right here. Typically, if it's coming from something, it'll be in here. If it's coming out, it'll be here. This is where you're going to get an issue with the VLAN or with the duplex mismatch, because you see collisions right here. But that's basically what I want to show you. So I am still in sub-interface command. So I'm going to go click up, and then enter. Now it'll take, because I told it what it's going to go for. So what I'm going to do is I'm going to type in interface fast. Theoretically, it probably would be easier if I just hit exit, because then I won't throw people off. Go interface fast 0/1.10. Okay, it automatically turns it on when you do this. There is no shut command in the sub interface. It's logical, which means as soon as you initialize it, it comes up. So we're going to type in IP address. Oh, can't do that. You got to type in encapsulation .1q10. So you're going to type in IP address. Well, actually, what I'll do is I'll hit enter a couple of times, and I'll cheat. 10 dot. There. This is actually how you do it when you're configuring in real life. You don't ever sit there and type out 100 commands all the way. There. So now what you do quickly now is going to be this. 20, and then you're going to type in this, and then you're going to be up and up, and one more. And as long as you get all of these done pretty quick, you're going to save yourself a lot of time. And as long as you make sure you, and there we go. Done. And now theoretically I should be able to show IP route. There they are. Now they're showing up. 10, 20, 30, and 1, 10, 20, 30, and 99. So, which actually would compute to that. So I just typed in all of that pretty quick. Now this is /0/1. Who cares? It really doesn't make a difference. But actually what I'm going to do is I'm going to scroll up real quick. And done. Now you see this right here? Right there. This is what you had to configure. So this is actually what I'm going to do next. I'm going to go under fast0/1, because actually I flipped the interfaces, and I'm going to configure that. So That'll be the next thing to do. Config T, interface fast0/1, IP address is going to be, gotta pull it back up real quick. Over here. I minimized it instead by accident. Be 172.17.50.254. 255.255.255.252. Because it's a point-to-point between a server and a fast Ethernet interface on a router, two interfaces, 2 points of connection, point-to-point connection. That's all I'm going to do. Enter. Do no shut. Now it comes up. Now what I'm going to do is, now if you do a do show IP route, and the 50 is in there now as well. It's /30, it's directly connected. And then all you got to do with this is minimize this guy, click on this guy, slide it over. And what I like about this guy is this is actually a rack server, and it's this actually could be theoretically flipped right side up, but this is actually a rack server. So I'm going to come over here to desktop, click on IP configuration, and then I'm going to type in 172.17.50.254. Subnet mask will be 255.0. Well, actually, I should type 252. And then 172.17.50.1. Or 253. Now I got to come back over here to the router and duplicate address 50.254. What does that mean? Oh, because I already configured that one as 254. See, I was being dumb. What does that mean? You're going to see that if you accidentally put the same, if it's down and then you apply an IP address, it's going to be like, hey, there's a problem with that. That's where CDP comes in. And let's actually show CDP neighbors. You see switch 1. It's not going to see the server because of the fact the server is not running any Cisco. So it sees switch 1 and it's on fast 5. So we're going to go into global config. We're going to go interface fast0/, what is that, fast0/1. We're going to type in IP address 172.17.50.253. 255.255.5.252. There. Now I should end ping 172.17.50.254. I know this will work. I'm very confident in my skills, or else I wouldn't be doing it. Now, pop quiz. I know the answer to this already, but I'm going to ask anyway. This guy right here is 172.17.50.254. Will this guy be able to ping this guy? Well, assuming that this host had an IP address and was pingable, would it still work? Negative. It would not. Why is that? Because it just won't. I'm just kidding. I'm serious. It still wouldn't work because this guy doesn't know how to get there, and there's multiple subnets, and it still wouldn't work. So this is 11, which I had to look at my documentation, is what IP address range? I didn't look before I put this in here. 11 is VLAN 10. So, desktop, click on this guy. This is 172.17.10. We're gonna put in 10. 255.0 and then 172.17.10.1. Bam. Now we should be able to ping our default gateway. 172.17.10.1. Either I'm full of crap or I know what I'm talking about. I leave it live just for the simple fact that people can see if I'm right or wrong. Okay, what's the problem now? Okay, we obviously have a problem, so let's figure out where the problem is. This is where troubleshooting your configuration comes in handy. So, Let me see here. Am I in the right VLAN? Fast Ethernet 11, VLAN 10. Who's in the right VLAN? Let's click on this guy. Actually, let's go back to the router once. I think it might be an ARP issue. Show ARP. 253, 254. Doesn't see it. Oh, you know what? I bet you I know why. Just thinking, Cisco CISCO enable class CLASS. We're gonna go and do a show run on fast 5. Notice how something real quick? Notice this guy right here? Nothing's there. So we're gonna go and configure that guy as a trunk port. So interface fast 0/5. Switch port mode trunk. So let's do it and do show ARP. 172.99.11. I don't know. Any guesses? Let's do a show ARP again on this guy and see what happens. Still nothing. What do you know? It worked. I'm going to assume that because it wasn't configured as a trunk port, that was the problem. I'm pretty sure that was the issue, because if you don't tell it because it was by default they're dynamic desirable, but now that's the case with that. So now I should be able to do a show IP route, and it's still gonna see it no matter what. These guys will know how to route to each other because of the fact that now I should be able to. Now I don't know if this is gonna work. I'm just trying something here. Ping 172.17.10.10, and it worked. Why does that work? Anybody have any answers? Well, Rob, it worked because of the fact it's directly connected. It's in the routing table. Well, absolutely. If it knows how to get there, it'll have a route to it. So you can. You're right. That is actually absolutely how it works. So, long story short, now question: if I configure this guy, and he's on fast. What port is this? Fast 18. And fast 18 is. I don't have it right in front of me. 1 second while I'm trying to figure this out. 18 is VLAN 20. Okay. So that means I have to configure this guy to 172.17.20.20. 255.0, 117.17.20.1. Can we ping our default gateway? That's the thing. If you can't route unless you can ping your default gateway, 117.17.20.1, we can ping our default gateway. And actually, let me move this out of the way here, just a little. There's no really good place to here. I'm gonna slide this down just a wee bit. Okay. I'm going to bring this back over here. Alright, so this guy right here is PC1. I'm going to pull this guy right here. I'm going to do this again. Now watch, what I want you to do is I want you to watch this guy, all these little flickering lights going up this way, okay? And, oh, it's not working the way I wanted it to. Can I do a ping? Can I do a... That's not going to work that way. Ping, actually, let's do this. Valid command, can I do a -T for a continuous? -T? No, it won't let me do that. It won't let me do a continuous ping, it'll just, ping. No, it's not going to let me do it. In Windows, you can do a continuous ping, and stuff like that, but yeah, it's not going to let me do that here. Now, can I ping my neighbor over here? Let's try. Ping 172.17.10.10. Why is that working? Anybody have any ideas? Well, Rob, it's because of the fact that the routes are up here. That's 100% absolutely true. You don't have to have a routing protocol running on the router in order for it to route your VLANs. You don't have to. It's just that simple. As long as you have directly connected routes and they can see each other, if it's in the routing table, it'll route. Simple as that. So, that's how that goes. Now, let me make sure I've got everything configured here per the cable network with the according to the topology diagram, clear configurations. This was a fresh set of configs. Performing basic configuration tasks on a switched LAN network. Configure VLANs and VTP on all switches, which I have, as you can see. Yeah. This is the VTP server, so it doesn't have to worry about it. This guy, however, will have a change. This will be different. 30, 10, 20. VLAN 1 is down. You want to leave VLAN 1 down. VLAN 1, it can get you in trouble. And then demonstrate and explain the impact of layer 3 boundaries imposed by creating VLANs. A VLAN equals a subnet equals a broadcast domain. So if you have a VLAN network similar to this, or any design really, anytime you have more than one virtual LAN, virtual local area network, you will have more than one broadcast domain. A broadcast domain by default is a broadcast domain. So if you have 10 VLANs, you have 10 broadcast domains. So and when you have a switch like this, you actually have 3, 4, 5 broadcast domains, because for each VLAN is another broadcast domain. Now, by default, on a layer 2 switch, you cannot have more than one management interface. You turn on the second one, it shuts the other one down. So, if I was to go in and turn VLAN 1 on, VLAN 99 would go off. It would get shut down. Now, if you have a layer 3 switch, like this guy, okay, and you were to go in here, and this is actually what grab it, zoom in, and I'll blow it up. This is a 3560, which they're kind of nice. Now, if you look, I can't really tell by looking at it what they are. This is the console cable. It's 24 ports, because this is usually designed for routing your VLANs using layer 3 switching. But let's see here. Advanced IP services 12.2. That's actually a pretty good one right there. But anyway, enable config T. I'm going to turn on interface VLAN 10, interface VLAN 20, interface VLAN 30, and show VLAN. Actually, I didn't turn them on. I didn't put an IP address on them, so this is actually a waste of time for me to even show you that. But that's let me get rid of this thing right here. No, I never do that because you never know what it's going to delete. But configure a router to support 82.1q trunking on a fast Ethernet interface. Configure a router with sub-interfaces responding to the configured VLANs. Demonstrate and explain inter-VLAN routing. I just explained that. That is 641 in a nutshell. Now let's make sure I'm going to bring this over here and see if I need to do anything extra. Pardon me while I just blast through this thing, because this right here is going to just give you setting up BTP. Like I said, BTP just takes your server and it replicates all the VLAN information down to all of your other check connectivity between VLANs. Actually, I did that, and then once I had, because this is above this is router, right? No, it's below router, or it's above router, which means you haven't configured routing yet, so it won't. I don't know what that was, but are the pings successful? They won't be until you actually start routing them. So I'm gonna, no, they were not. Control Z. I don't know what that did. No. And if not, why do these pings fail? They fail because, actually let me Oop, too far. They end because there is no routing in place to route the VLANs from one subnet to another. So that is why they won't route. That's why they won't ping. Now, I think it's right down here. PC1, can you verify you can ping? Well, let's try real quick. PC1, we'll say this is PC1. Can we ping 172.17.50.254? Yes, we can. Reflection. In task 5, it was recommended you configure VLAN 99 as the native VLAN for the router. Why would packets from the router or host fail when trying to reach a switch management VLAN if the native VLAN were left in default? Good question. Did I even set that? I don't think I did. Config T, conf T, whatever you want to type. Interface fast 0/0.99. Encapsulation .1q 99 native. There. What that does is it's actually a really good point, and I apologize for missing that because I actually hadn't gone this far down. Or actually, I missed a little section is what it is. Didn't go that far down. What that does is if you do not keep the native VLAN throughout the entire the routed domain, so from the router down through the rest of your network, that's where you can get the VLAN leaking again because you're bringing your VLANs into your router, and if the router doesn't know what to do with them, it could possibly spread. So if the native VLAN was VLAN 1, it could possibly, create a potential hole in your security, and that wouldn't be good. So, I'm gonna take this guy and I'm gonna delete it. Actually, I'm gonna delete this whole thing and go File, Save As, and we're gonna do this will be 6-4-1, and I want to get it out of here, and I want to and save. Okay. So that's how you do that. Now, if you don't care to know all that information, fine by me. I thought it'd be helpful, but maybe not. So I hope this has been informative for you, and I'd like to thank you for viewing.